The NFPA World Safety Conference approved a proposal to revise NFPA 13, NFPA 24, and NFPA 54. These revisions clarify that underground pipe systems must be bonded to the lightning protection grounding system. This bonding is required even though the piping itself is not permitted to be used as grounding electrodes. Section 10.68 of NFPA 13 and 24 will be revised to explicitly require the bonding of underground piping to the lightning protection grounding system when lightning protection is provided for a structure. The rationale behind this change is to ensure a common ground potential. This prevents potential differences between underground piping and the lightning protection system. Underground piping is not permitted to be used as grounding electrodes. When galvanic corrosion is a concern, bonding can be achieved through a spark gap or a gas discharge tube. These revisions aim to enhance safety. They ensure that underground pipe systems do not become a hazard in the event of a lightning strike. NFPA 780, Section 4.14 requires that all grounding media, including underground metallic piping systems, be interconnected to provide a common ground potential where lightning protection is provided for a structure. These underground piping systems are not permitted to be substituted for grounding electrodes but must be bonded to the lightning protection system. Where galvanic corrosion is of concern, this bind may be made via a spark gap or gas discharge tube. The key changes involve a clear mandate to bond underground piping to the lightning protection grounding system when lightning protection exists. This bonding is crucial to maintain a unified ground potential, mitigating risks associated with lightning strikes. The revisions explicitly state that underground piping cannot serve as grounding electrodes, emphasizing the specific purpose of the bonding requirement, which is to equalize potential rather than provide a grounding path for electrical services. The allowance for spark gaps or gas discharge tubes in the bonding connection addresses concerns about galvanic corrosion between dissimilar metals in the piping and grounding systems. This approach enables the necessary electrical connection for lightning protection while minimizing the risk of long-term corrosion issues. The impact of these revisions is significant for enhancing safety by reducing the potential for hazardous voltage differences during lightning events. By ensuring that underground piping is properly bonded to the lightning protection system, the risk of electrical arcing and potential damage to equipment and structures is minimized. This update to the NFPA standards provides clearer guidance and requirements for electrical engineers, contractors, and inspectors. It ensures consistent implementation of lightning protection measures in buildings and facilities. The revisions reinforce the importance of a comprehensive approach to grounding and bonding. It recognizes the potential hazards associated with underground metallic piping systems in the context of lightning protection. The use of spark gaps or gas discharge tubes provides a practical solution to address galvanic corrosion concerns without compromising the effectiveness of the lightning protection system. These changes reflect ongoing efforts to improve safety standards and adapt to evolving knowledge and best practices in the field of electrical engineering and lightning protection. The update clarifies the roles of different components in the grounding and bonding system. It distinguishes between grounding electrodes, which provide a path to earth, and bonding conductors, which equalize potential between different conductive elements. This distinction is important for understanding the specific requirements and intended function of each component. The revisions emphasize the importance of considering galvanic corrosion in the design and installation of grounding and bonding systems. This is a critical factor for ensuring the long-term reliability and effectiveness of the system. The use of appropriate materials and methods, such as spark gaps or gas discharge tubes, can help to mitigate the risk of corrosion and maintain the integrity of the electrical connections. The changes highlight the need for coordination between different trades and disciplines involved in the construction and maintenance of buildings and facilities. Electrical engineers, plumbing contractors, and lightning protection specialists must work together to ensure that the grounding and bonding system is properly designed and installed. This collaboration is essential for achieving the desired level of safety and protection. The revisions serve as a reminder of the importance of staying up to date with the latest codes and standards. These codes and standards are constantly evolving to reflect new knowledge and best practices. By staying informed and adhering to these requirements, professionals can help to ensure the safety of people and property. The revisions underscore the importance of a holistic approach to safety. This approach considers all potential hazards and implements appropriate measures to mitigate those risks. Lightning protection is just one aspect of overall safety, but it is a critical one, especially in regions with high lightning activity. By addressing the potential hazards associated with underground piping systems, these revisions contribute to a safer built environment. The updates to NFPA 1324 and 54 concerning underground pipe bonding to lightning protection grounding systems address several key areas to enhance safety and clarify requirements. Firstly, the updates emphasize the critical distinction between using underground piping as grounding electrodes and bonding it to the lightning protection system. The revised standards explicitly prohibit the use of underground piping as grounding electrodes for electrical services. Instead, they mandate that such piping must be bonded to the lightning protection grounding system when lightning protection is provided for the structure. This clarification prevents misunderstanding and ensures that the piping is not improperly relied upon for grounding purposes. Secondly, the rationale behind these changes is to ensure a common ground potential, which is essential for mitigating risks during lightning strikes. When lightning strikes a structure, it can create significant potential differences between various conductive elements. By bonding underground piping to the lightning protection system, a common ground potential is established. This reduces the risk of dangerous voltage differences that can lead to electrical arcing, equipment damage, and even fire hazards. Thirdly, the revisions address the issue of galvanic corrosion, which can occur when dissimilar metals are connected in the presence of an electrolyte, such as soil. To mitigate this concern, the updated standards allow for the use of spark gaps or gas discharge tubes in the bonding connection. These devices provide an electrical path for lightning surges while preventing continuous current flow that could accelerate corrosion. This approach balances the need for effective lightning protection with the long-term integrity of the piping system. Fourthly, the impact of these revisions is far-reaching, affecting the design, installation, and maintenance of building systems. Electrical engineers, contractors, and inspectors must be aware of these changes and ensure compliance with the updated standards. The proper bonding of underground piping to the lightning protection system is crucial for ensuring the safety of occupants and protecting property from the damaging effects of lightning strikes. Fifthly, the revisions also highlight the importance of coordination between different trades and disciplines involved in building construction and maintenance. Electrical contractors, plumbing contractors, and lightning protection specialists must work together to ensure that the grounding and bonding system is properly designed and installed. This collaboration is essential for achieving the desired level of safety and protection. Sixthly, the updates underscore the need for ongoing education and training in the field of electrical safety. As codes and standards evolve, it is important for professionals to stay informed and up to date on the latest requirements. This ensures that they can effectively apply the standards in their work and contribute to a safer built environment. Seventhly, the revisions to NFPA 1324 and 54 reflect a broader trend towards enhanced safety and risk mitigation in building design and construction. These changes are driven by a growing awareness of the potential hazards associated with lightning strikes and the importance of implementing effective protection measures. By addressing the specific issue of underground pipe bonding, the updated standards contribute to a more comprehensive approach to lightning protection. Eighthly, the allowance for using spark gaps or gas discharge tubes to mitigate galvanic corrosion is a practical and effective solution that demonstrates a commitment to both safety and long-term system reliability. These devices provide a necessary electrical connection for lightning protection while minimizing the risk of corrosion-related failures. This approach is consistent with the overall goal of creating building systems that are both safe and durable. Ninthly, the clarification regarding the use of underground piping is essential for preventing misinterpretations and ensuring consistent application of the standards. By explicitly prohibiting the use of underground piping as grounding electrodes, the revisions eliminate any ambiguity and ensure that the piping is used only for its intended purpose of bonding to the lightning protection system. This clarity is crucial for avoiding potentially dangerous situations. Tenthly, the emphasis on a common ground potential highlights the fundamental principle of lightning protection, which is to equalize potential differences and prevent electrical arcing. By bonding all conductive elements together, including underground piping, a common ground potential is established, which minimizes the risk of dangerous voltage differences during lightning events. This principle is essential for ensuring the effectiveness of lightning protection systems. 11thly, the impact of these revisions extends beyond new construction to include existing buildings and facilities. While the updated standards primarily apply to new installations, they also serve as a reminder for building owners and managers to assess the lightning protection systems in their existing buildings and ensure that they are in compliance with current codes and standards. This proactive approach can help to identify and address potential safety hazards before they lead to serious incidents. The updates to NFPA 13, NFPA 24, and NFPA 54 are significant because they address a specific potential hazard related to lightning protection and underground piping systems. By mandating the bonding of underground piping to the lightning protection grounding system, the revisions aim to prevent dangerous voltage differences and ensure the safety of building occupants and property. The revisions provide clear guidance and requirements for electrical engineers, contractors, and inspectors, ensuring consistent implementation of lightning protection measures in buildings and facilities. The allowance for spark gaps or gas discharge tubes provides a practical solution to address galvanic corrosion concerns without compromising the effectiveness of the lightning protection system.